Everything you think you know about the beginning of everything is probably wrong. Forget the image of an explosion in empty space. The Big Bang was not an explosion. It was the beginning of space and time itself. And if that's the case, what did the universe expand into? What if I told you that the beginning might not have been the true beginning? Stay tuned, because today we're debunking the biggest myths about the universe. And I'll show you how everything you see and are came into being from a state that was unimaginably hot and dense. You look up at the sky at night and see stars, perhaps the Milky Way. It feels infinite, peaceful, but this tranquility is deceptive. You are looking at a vast, dynamic arena in which an incredible story has been unfolding for 13.8 billion years. A story in which you are the main character, because the rules that were established on the first day of the universe still determine your life today. The only problem is that most of us have a completely wrong picture of this story. In this video, you will get the complete, factually accurate narrative, from the first moment to the present day. And by the end, you will not only understand what the universe is, but also why its creation is the most incredible story ever told. To understand how it all began, we must take a journey, not to a place, but to a time before time. 13.8 billion years ago, there was no space as we know it. There were no stars, no galaxies, not even atoms. Everything, absolutely everything, all the energy and matter in the observable universe today was concentrated in a point of unimaginable density and heat, a point smaller than a single atom. Physicists call this state a singularity, and this is where the first decisive moment occurs, the Big Bang. But it was not a bang in an existing space. It was the creation of space itself. Imagine it like this. Space itself began to expand everywhere at once, like yeast dough rising and pulling the raisins inside it, the future galaxies, along with it. The question, what is the universe expanding into, is therefore misguided. It is not expanding into anything. It is the expansion. More happened in the first fractions of a second than in the billions of years that followed. Immediately after the start, there was a phase we call cosmic inflation. In an unimaginably short moment, the universe expanded exponentially, from subatomic size to that of a golf ball. This inflation is one of the most important ideas in modern cosmology, because it explains why the universe is so incredibly large and uniform today. But what the real reason for this extreme expansion was, is one of the greatest mysteries that science is still working on. After this phase, the universe was a hot, dense soup of fundamental particles. Quarks, electrons, photons, everything swirled chaotically together. It was so hot that not even protons and neutrons, the nuclei of atoms, could form stably. Every time they came together, they were immediately smashed apart again by a high-energy light particle. The universe was an opaque fog of pure energy, but as the universe continued to expand, it cooled down, and after about 3 minutes, a magical point was reached. The temperature had dropped enough for the first stable atomic nuclei to form, hydrogen and helium. To this day, these are by far the most common elements in the cosmos. Over 99% of the visible matter that came into being at that time consisted solely of these two elements. But the universe was still an opaque fog. Why? Because the free electrons constantly deflected the light. You wouldn't have been able to see anything. Now comes a decisive moment that the universe had to wait 380,000 years for. The temperature continued to drop to about 3,000 degrees Celsius, cool enough for the atomic nuclei to capture the free electrons and form the first neutral atoms. At that moment, the universe suddenly became transparent. The light that had been trapped until then was able to spread freely for the first time. And we can still see this very first light today. It is the cosmic microwave background radiation, an echo of the Big Bang that comes from all directions in the sky and provides us with a baby photo of the universe. The biggest mistake many people make is to think that this fireball was in one place. No, it was everywhere. We are right in the middle of it. Then began a long dark period, the Dark Ages. There were no stars yet to provide light, only huge clouds of hydrogen and helium drifting slowly through space. But gravity is patient. Over millions of years, it pulled these gas clouds closer and closer together. In places that were slightly denser due to tiny density fluctuations from the inflation phase, matter began to clump together. And after about 200 to 400 million years, it happened. In the centers of these collapsing gas clouds, the pressure and temperature became so extreme that nuclear fusion ignited. The first stars were born, enormous blue giants, 100 times more massive than our sun, shining millions of times brighter. They ended the Dark Age and began to flood the universe with light. These first stars were cosmic alchemists. In their cores, they fused hydrogen and helium into heavier elements: carbon, oxygen, nitrogen, all the elements that you and I are made of. When these giant stars died in violent supernova explosions after only a few million years, they hurled these newly forged elements into space. They sowed the seeds for the next generation of stars and planets. These enriched clouds then gave rise to the first galaxies, huge collections of stars, gas, and dust held together by gravity. And here we encounter another mystery: dark matter. Astronomers realized early on that galaxies rotate so fast that they should actually fly apart. Visible matter alone cannot hold them together. There must be an invisible form of matter that has about 5 times more mass than anything we can see. We don't know what it is, but we see its effects everywhere. It is the invisible skeleton of the cosmos on which galaxies form. And as if that weren't strange enough, an even more shocking discovery was made in the 1990s. It was thought that the expansion of the universe would be slowed down by gravity, but the opposite is true. It is accelerating. There must be an even more mysterious force, a kind of anti-gravity that is driving space apart. We call it dark energy. It accounts for almost 70% of the total energy content of the universe. This means that everything we know, stars, planets, you and me, makes up less than 5% of the universe. The rest is a complete mystery. So let's summarize. The universe is not just the space around us. It is a 13.8 billion-year-old, acceleratingly expanding space-time structure. It began in an unimaginably hot, dense state, expanded explosively, cooled down, became transparent, formed stars and galaxies, and today consists of 95% completely unknown substances. What can you take away from this? 3 things. First, you are part of this story. Every atom in your body was forged in stars and has been traveling through the cosmos for billions of years. Second, science is a process, not a collection of facts. We know a lot, but the biggest questions, what came before the Big Bang, what is dark matter, what is dark energy, are still unanswered. And third, the next time you look up at the night sky, you're not just seeing lights. You're seeing a time machine. You're seeing the history of the creation of everything that exists, and you are living proof that the universe has found a way to reflect on itself. And that, my friend, is a realization that changes everything. If you are eager to learn and want to educate yourself, sign up for a free subscription now.